My apologies again to the online people.
And I was like, wait, I didn't need to do this.
I just start naming out.
I have to turn on the recorder before I take care of this stuff. Let's see if it works. Let's see if it works. Wow. Row 1 isn't great. Are you guys coming to row 1? All right. All right. Now what's it doing? Have to do this twice, huh? Is it up there? For those of you who didn't get your test the other day, I'll be here after class today. Looks like we're there. Okay, again, I apologize to the online people for how long this has taken to set this thing up. But what can I say? Just having trouble figuring out how to make this thing work. But we're on page 70, exercise 2.2. Let's pray. Father, help these students to understand this section and help me to explain it well. In Jesus' name we pray. Amen. Page 70. Have you noticed, if you read the pages that I send you an announcement about before you come in here, it helps you follow what we're doing in class? Have you noticed that? Well, some of you might not notice it because you're not doing it. I've noticed on the attendance sheets that about 30% of you are not reading the pages. But do the other 70% notice that it helps you to read the pages? Thank you. Thank you. Thank you. So now we have what we're doing here on page 70, exercise 2.2, is we're doing intersections and unions. In problems 1 through 8, let A be the set 1, 2, 3, 4, 5. So A is 1, 2, 3, 4, 5. And B is the set 1, 3, 4, 6. And 6. Erase that 4 and try to do it better, Tom. Okay. 4. Put commas in here. Put brackets around it. Those squigglies. And C is the set 1, 6, 7. Find the following. Exercise 2. 2A. What does 2A say? Can you read that? A, U, B. And that means union. U for union. So what letter would we use for intersection? I? That would make sense, wouldn't it? Well, don't count on it making sense. Just learn how to do it and write notes. U is union, intersection. Is an upside down U. Okay? If you don't put that in your notes, you probably won't remember it when it comes test time. So now let's look at 2A. It says take set A, that's 1, 2, 3, 4, 5, and set B, 1, 3, 4, 6. Can you make a better 4? I'll try. But I'm having trouble today. 1, 3, 4, 6. And unite them. Put them together. So what set would I end up with when I unite those two? 1, 2, 3, 4, 5. And then what's 1, 3, 4? I have to add 6. Everybody follow that? I've got all the first set plus the stuff in the second set that I haven't already listed. You put the two together. You say, well, wouldn't you just put 1, 1, 2, 3, 3, 4, 4, 5, and 6? You could, but you don't have to duplicate them. Duplicates don't really count. So that's the union. That's 2A. So what if it said A intersect B? That's not there, but it should be. So let's just put it in there and work it for problem 2. What if it said A intersect B? What do you think that would be? An intersection is where two roads have the same pavement in both of them. So what's in A that's also in B? 1, 3, 4. Everybody follow that? Union means you put them together. Intersection means you find the elements they have in common. By the way, in your reading, union is on page 65 and intersection is on page 64. If you want to go back and look at it and read it while we're talking about it to help make sense out of it. Any questions? Let's do 2B. What's that all about? Whoops. Why won't it go up on it? There we go. You weren't talking nice to it, Tom. Like Alexa. You talk mean to her, she won't cooperate. 2B. A union C. So now I bring it back down. What was A?
1, 2, 3, 4, 5.
And C?
1, 6, 7.
So the union of A and C would be
1,
2, 3, 4, 5, 6, 7. Everybody follow that? So what's 2C? The union of B and C. What's B?
1, 2.
What's C? So the union of B and C would be 1, 3, 4, 6, 3, 4, 6, and 7. Everybody follow that? Well, that's all there is to it. Oh no. Number 4. What happened here for number 4? For A. Anyone see a mistake I made? Is that what 4A says? No, it says A intersect B. If you copy it down wrong, you'll definitely miss it. Now let's go back up here and look at A and look at C, and we're looking for the intersection. We're looking for the elements that are in both of them. A 1. Is that it? So I come down here. The intersection of A and B is the set whose element is 1. Everybody follow that? Yes? Oh, I did A and C, didn't I? Yeah, I did A and C. I had C on my mind because I copied it down wrong and I just kept doing it. What's wrong with me? A and B. So that would be the intersection. 1, 3, 4. Everybody agree? 1, 3, 4. Are we all looking at the same thing and coming to the same conclusion? And why did we do this first? Because it's in parentheses. Always write yourself a note. Always do the parentheses first. And so now I want to take this and unite it with what? C. What was C? 1, 6, 7. So sometimes I just do this down there when I'm working them. 1, 6, 7. So I kind of, instead of trying to do it all in my head, so now I'm going to unite 1, 3, 4 with 1, 6, 7, and what will I end up with?
1, 3, 4, 6, 7.
All right? That's the way I would show my work on that. So now let's go down to 4B. A intersect B. Union A intersect C. What's A intersect B? See, this is why when I have my work down here, A intersect B is 1, 3, 4. See, I can just look back at the previous problem. 1, 3, 4. And A intersect C, A, get out of here. A intersect C, that was 1, wasn't it? So A intersect C is 1. And what am I supposed to do with those? Unite them. So what do I get when I put them together? 1, 3, 4. Everybody follow the process? Well, then we're on our way. In problems 9 and 10, let A is the set and B is the set and C is the set Have I copied them down right? Check to see. If they're copied down wrong, we'll miss it for sure. Okay, now we're ready to do problem 10A. A union B. So what's in A? The little set AB. And C. Agreed? What's in B that I haven't listed yet? I've listed C, haven't I? But I haven't listed A or B. Everybody agree? See, the elements of A are a little set AB and the letter C. The little set AB is different from A and B out by themselves. Those are different elements of the set. What's A union C? Here's A, which is this little set AB, and then C, and then I add to that A and B. Everybody follow the process? Good. Problems 11 through 14. Wow. That's a mess. I'm not going to copy all those over. I just want you to look at them in the book. So the people online will have to get your book out on page 70 and look at that problem. But let's do problem number 12. The set AB What's the intersection of A and B? What do A and B have in common? They both have this little AB, right? Is that right?
Yeah.
Do they both have the little set ABC? No. Do they both have an A? Oh no, I'm doing intersection. Do they both have an A?
Yes.
So I put A down here. Do they both have a B? Yes, so I put B down here. So do you see how I found the intersection of A intersect B? I looked at A and said, what does it have in common with the set B? Now I've written it down here. Now here's the question. Is this set, can you read that symbol? It's on page 57 in your textbook. So you better put that in your notes. Can anyone tell me what that symbol means from looking at page 57?
A is a subset of B.
Is this little set a subset of this?
Yes.
Yes. Everybody follow that? Is this little set AB, there it is right there. See that? It's an element, it's a not an element, it's a subset of this set. Let's do number 14. Okay, we've already got A intersect B, don't we? Here's A intersect B right here. Is 3 a subset of that? No. So that's incorrect. I think that's what they want you to say. What? Which of the given statements are correct? And this is incorrect. Okay. So you know how to read this. How did you say you read that? Do they have any with just? Oh, I guess they don't. What if it would have just been this thing like this without the little line under it? That's on page 58. Proper subset. This is subset here. This is proper subset. Now, one way to distinguish those, see this almost looks like, you know how you remember studying less than or equal to? Well, this is almost like it's a subset or it's equal to it. But this is a subset, but it can't be equal to it. Because if it's equal to it, that's not part of a proper subset. Does that help make sense to you? And put that in your notes and bring it with you when it comes test time. Because he'll test you. The test will test you on that kind of information. All right, we're ready for a new topic. Complement of a set. The universe is what? A is the set ACE. B is the set BDEF. And C is the set ABDF. One of the reasons I copy them over when I can, when I'm working them, is it actually starts fixing in my mind the universe and the sets A, B, and C. You see what it's doing? By copying them over, I'm kind of sticking them in my mind so I can answer the questions. Because the first question, number 16, A says, does anyone know what that little mark above A stands for? That's on page 65. Look at page 65 and see if you can read this. Can you read that A with the little mark on it? From page 65? Did I give you the wrong page? That's the complement of A. It's not A, it's the complement of A. Now, do you know what the complement of A is? I'm about to tell you. Put it in your notes. The complement of A is everything in the universe that's not in A. So let's put this down here. The complement of A is everything in the universe that's not in A. Okay, here's the universe. So down here, is A in A? So I don't put it there. Is B in A? Nope, so that's part of the complement. Is C in A? Yes, so I don't put it there. Is D in A? No, so that's part of the complement. Is E in A? Yes. So I don't put it there. Is F in A? No. So F. So the complement of A is everything in the universe that's not in A. So I take out A, C, E, and it leaves me with B, D, F. You follow the thinking? Good. So now I've written down here the complement of A. So now I come over here, and what am I going to write? The complement of B. Here's B, B, D, E, F. Here's the universe, A, B, C, D, E, F. What's in the universe that's not in B? A, B's in there, C, D's in there, E's in there, F's in there. You follow what I'm doing? So the complement of B is the set whose elements are A and C. Everybody follow that? Do we need to count to 3 and say math is stupid? Just to get rid of the tension? Let's do it. 1, 2, 3. Math is stupid. There you go. You got it out of your system, so now we can go work some more problems. All right. So now we're not finished yet because we want to find the what? Look at your notes. What's that symbol stand for?
Intersection.
The intersection. The intersection of these two sets. What's the intersection of these two sets? What do they have in common? Nothing. So what do I put out here? You put something that stands for nothing. You can either do it this way with nothing in it, or you can do it this way, which means what? Empty set. Either way would be a correct answer. Well, wasn't that fun? Let's do 16b. (16b) A intersect B, and then the complement of that. Isn't that what it said? So what's the intersection of A and B? Here's A, A, C, E. Here's B, B, D, E, F. Intersection means what they have in common. So what do they have in common? E. Everybody see that? So E is the intersection of A and B. Now what's the complement of E? Everything in the universe that's not E. So the answer would be A, B, C, D, F. Everybody follow that one? Fantastic. Fantastic. We are on a roll. Let's go to problem set C. Now, understand, just like I'm limited, if I erase this, then people who look at this can't see it. So I'm limited as to how much I can work on this screen. So if you're looking at some of these and you're having problems with them, class is going to end at about 10:30. I'm going to put the screen up, and I brought some markers with me. So I can, if you're looking at one of these problems saying, that one scares me, then just come up here to the front row, and I will work through it with you on the board and show you how to think through it. But it's basically it's this same process. So let's go to a new process called what? The difference of two sets. The universe is 1, 2, 3, 4, 5. A is 2, 3, 4. B is 1, 4, 5. Did I copy them down right? 28. 28A. So, you could probably read that. That says A minus B. Does everybody see that? Where it says A minus B. Okay? Oh, turn it back down so you can see all this information. So, where's A? 2, 3, 4. What's B? 1, 4, 5. Okay, subtract B from A. Is there a 1 over here? So I can't do anything. Is there a 4 over there? So I take the 4 away. Is there a 5 over there? Is there? I can't take a 1 out because there's not a 1 to take out. I can't take a 2 out because there's no 2 here. Remember, I'm subtracting B from A. I'm taking everything in B out of everything that's in B that's in A. I'm taking it away. Is there a, here's a 4. Is there a 4 here? Yep, so I take it away. Is there a 5? No, so I do nothing with it. So A minus B would be what? 2 and 3. That's it. Do we need to count to 3 again? And say, that's really stupid. Yes?
You remember in like grade school when the teacher would, you'd notice that all the kids are losing focus and they'd make you get up and like flail your arms around?
Is that what you feel like
I think
doing?
That's what we need to do actually.
Then if that's what they did and it helped, you're welcome to stand up and flail your arms around and I'll know exactly what's going on. You, whatever it takes to get the stress out of your life so you can do some more of this, just stand up and do it and we'll be on our way. But this is not like subtraction with numbers, is it? It's a different kind of subtraction, and that's going to bother some of you a whole lot. It's just going to bother you because it looks like something you've seen, but it's not exactly like what you've seen. It's different, and that bothers me. So let's do 28B. And it's okay to be bothered, just get over it so you can work the problems when it comes time to take the test. 28B, B minus A. So this time, what we have first is 1, 4, 5. And A is 2, 3, 4. So what do I take away from B? The 4, right? So what's the answer? 1 and 5. Fantastic. Okay? All right. Now we're going to get really philosophical here. In problems 29 to 38, U is some universal set. U is some universal set of which what? A is a subset. All right. And the answers, the choices for answers are A, universe, or what does that stand for? What does that stand for? empty set. A, universe, or empty set. This is empty set. And it says empty set alone. And the reason they say alone is because isn't empty set in every set? You figured it out from the topic 2.1. Empty set is a subset of every set. Because if you take everything out of the set, what are you left with? An empty set. So that's why they say, no, here the answers are either A, the universe, or the empty set alone, the empty set by itself, not as a subset. So let's look at problem 30.
So, would the complement of the universal be nothing?
There, the complement of the universe would be nothing, and how would I say nothing? The empty set alone.
And then 29 would just be the reverse of that, right?
Okay, so let's look at 29. See, that's one of ours. I know, but since somebody asked, let's work it. The complement of the empty set would be what? The universe. There you go. Do you feel like a philosopher now? A mathematical philosopher? Number 32. The intersection of A with A would be what? I have three choices. A, the universe, or empty set alone. It'd be A, wouldn't it? Doesn't every set, when it intersects itself, it would be that set again? 34. A, union, empty set. What would that equal? A. All right. See, it's not so hard. It's not so hard doing mathematical abstraction. That's what they call it. They call it philosophy when you're over in words. With math, they call them abstractions. 36. That looks like a fun one. 36. A, union, the complement of A. If I take A and its complement and I put them together, what do I have? The universe. Everybody follow that one? Because the complement of A is everything in the universe that's not in A. So if I put those two together, I unite them, I've got the universe. You guys are good at this. Okay, let's do some applications. Problem number 40. Find the smallest set that will serve as a universal set for the smallest set that will serve as a universal set for MW. So if I want the universal set for all of these, then that means I want to put all of these together, right? So under MW, what does MW stand? M sub W stand for? Traits men like in women. And what would that be? This one would be beauty. Aren't men so shallow? Intelligence, well, they're getting better. Cheerfulness and congeniality. You follow me? Now, what do women, W sub M, want? Intelligence, consideration, kindness, and cheerfulness. Well, that's everything men want in women, except for what?
Is this a
You got it, guys? You're looking for beauty, and she wants kindness. You don't know what kindness means? Ask her, she'll tell you. And then be kind. What do men like in men? M sub M, intelligence, cheerfulness, friendliness, and congeniality. And what do women like in women? Intelligence, cheerfulness, helpfulness, and loyalty. Now, my universe is going to have all of that stuff in it. So what's it going to have? Beauty, intelligence, cheerfulness, consideration. I've got intelligence, consideration, cheerfulness, then I need to add kindness, intelligence, cheerfulness, friendliness. Is that what that is? And then helpfulness and loyalty. You follow what I did to get that? Yes.
There's two words that start with con. There's congeniality and consideration.
Oh. That women like in men? Consideration, kindliness, and cheerfulness. Did I leave something out?
Yeah, there's.
Oh, congeniality. There's congeniality, and then there's consideration, isn't there? Yeah. Does that get them all when I put consideration in there? Good. All right. Sorry about that. Too many cons. Should have put a con S and a con G. Well, there you go. 42. Find the intersection of M sub W intersect W sub M. M sub W. That's right up there in the first one, isn't it? Traits men like in women. And what was that? Beauty, intelligence, cheerfulness, and congeniality. What did women like in men? Intelligence, consideration, kindness, and cheerfulness. Where do these intersect? Intelligence, cheerfulness. Is that it? See how that works? See how, and when I say show your work, you see what I'm doing? I'm taking these letters and I'm writing down here, and then I'm looking for the ones that match. So I'm thinking it through, because if you just try to do it all in your head, you'll probably make a mistake. And then when you grade your paper, you go to the back of the book and grade your paper. You say, I missed it, but then you don't know what you did, so you don't know why you missed it. So it helps to write down your thinking on the paper while you're working through it. So when you check it, if you missed it, you know why you missed it. Okay. Number 44. What set of traits is common to M sub M and M sub W? What do you think it would be for is common? Would is common be intersection or union? Intersection. Good for you. You say, I was thinking union. Well, you were thinking wrong, but don't be surprised by that. We just naturally think good math. No, we naturally think erroneous math many times. So just say, okay, when it says is common, that's intersection. What's common to both? And now you know what is common means. Now you can work the problem. Okay. Let's jump down to number 46. Are we moving fast enough through here? Yeah, I guess we are. Find S sub 1 intersect S sub 2. And what is S sub 1? The set of traits mentioned in the first year. So see where it says first year in the blue box? I put next to first year, I put a little S sub 1 in there. And the second year is S sub 2, so I put a little S sub 2 in the blue box next to the second year, so I'm keeping straight in my head what I'm looking at here. And now I want to go around the left-hand column and see where it intersects with the right-hand column. And I'm just going down the left-hand column. Is encourages suggestions in there?
Yes.
So I put encourages suggestions, because that's in both of them. Is sets goals with me? Is that in there? So I put sets goals with me in there. Is gets me to have high goals? I'm looking down the left-hand side. Is gets me to have high goals in there? Yes. Is listens carefully? Yes. Is aware of others? No. So I don't put that down. Is self-aware? Yes. So I put SA, and that's my intersection for those two sets. See the process of how you walk through it, just looking at them? In problems 51 through 57, this one gets a little complicated. The universe is the set of employees for a company. M is the males who work there. F is the females who work there. D are the people who work in data processing. T are the people under 21. And S are the people over 65. That's a lot of stuff to keep straight, isn't it? 52. A. M. Union F. If I put all the males in the company and all the females in the company together, what do I have? Everyone who works at the company? Maybe that, but what do I have in terms of this stuff here? The union would be, I would have the universe, wouldn't I? Everyone who works at the company. 54B, 52B. M intersect S. And what would that be? Where the males and the females overlap. Empty set. They don't. Say, well, in some places they do. No, in some places, some people are confused about where they belong. But if they need help, you could straighten them out. Number 52C. T intersects S. What's T? The people under 21. What's S? The people over 65. Where do they intersect? They don't. So that means empty set again. 54. A. M. Intersect the complement of T. All right, so what's M? the males. What's T? So the complement of T would be employees over, or employees, if it's under 21, to be 21 and over, right? Would that be right? Oh, verbally describe. So what would be the verbal description of this?
The set of all male employees 21.
The set of all male employees that are, who are what?
21 and over.
Yep, who are 21 and over. There you go. Okay. Now, for problem 56, they want you to find a set representation for this. So, female employees under 21. So that would be females, right? But I don't want all the females. I want where the females intersect with T. Everybody follow that? Good for you. Page 72. Stop when you get to number 75. 75 is the last problem you work on this page. Let's do number 68. The set of cars made by Honda. What did I do? 68. The set of cars made by Honda. One is made by Honda. What else?
4.
And 4. 1 and 4 are made by Honda. 72. A customer wants to purchase a car on the basis of total annual cost. Find the set of cars with annual cost under $8,000. Annual cost under $8,000. Look down the annual cost column, right-hand column. Are there any numbers under 8,000? 4. And what else? And 6. Is that it? Well, that explains a lot. I'm known in my family as a cheapskate, or a bargain hunter, or a guy who doesn't like to waste money, or a guy who enjoys teaching and has figured out how to live on a teacher's salary. There's all kinds of ways to describe it, but most of my relatives just say Tom is just cheap. They make jokes about when I was just at a family reunion, and they said, yep, when Uncle Tom takes his kids shopping for school clothes, he goes, let's head to the thrift store. I said, there you go. And then they all laugh. I'm thinking, I'm the one laughing. They've got bills to pay for 6 months, and I've still got money in the bank. Because I went to Red Rack after church on Sunday and bought clothes for 50 cents. You say, well, not everything's on sale for 50 cents. Well, my daughters learned that you buy what's for 50 cents. If you want something else, pay for it yourself. And sometimes they did, but most often they picked up the 50-cent stuff and went on their way. And you know what's the cool thing about buying a shirt like this for 50 cents? If I'm home eating chili and I get a stain on it, and my wife says it won't come out, I'm going to throw it away. It's just 50 cents. I didn't ruin a $10 to $15 shirt. Give me a break. No, she says, it's a nice shirt. Don't get stains on it. Okay, and by the way, this is what explains something for me. So what kind of cars do I drive? Honda Civics and Toyota Corollas. I don't like the name of either one of them. One sounds like a stinky cat and the other one sounds like a cigar. But I don't care what they call them. I look at what it costs to operate them and I say, give me the cheapest one. That's the one I'm going with. All right. Enough of that. 74. Find a set of cars with the total annual cost under $7,000. Well, that's easy enough, isn't it? Yeah, if I can find a cost under $8,000, let's find one for under $7,000. And what's the answer? Empty set. Get a bicycle. If you're really that cheap, get a bicycle or a little motor scooter. All right, stop when you get 75, and sure enough, it's 10:30, and we're done with this. So we've got 30 minutes for me to stay here and answer your questions and help you with this stuff if you need some help on the board.
And it seems like there's nothing. I'm like behind on school.
Put homework on the table.
Yeah.
What?
Homework on the table.
Yeah, put your homework on the table, and if you want to stay, thanks. Appreciate you doing that. If you want to stay and work on your test, just stick around and I'll give you your test and you can work on that too.
Yeah. So I gotta go to the library after chapel today. And yeah, I'm trying to get all my math done like I was here last night. That's all right.